we are kicking off the school year with CO1. As was explained yesterday, Unit 1 is going to be a lot of foundational, a lot of kind of nuts and bolts, basic stuff of what math has to offer. Some new stuff, though, too. Scientific notation, CO5, or arithmetic sequence, and CO8, just to name a couple. But we are going to start with rational and irrational numbers, which, if you remember, those of you who kept your binders from pre-algebra,
I didn't.
CO1 in pre-algebra has to do with whole numbers, integers, rationals, and irrationals, but now we're just going to focus on the rational and irrational. So, just a reminder, these icons here, those wise old owls are not frogs, they're wise old owls. Those are definitions, those are terms. Can they go on a help sheet?
Yes.
Yes. Can the key points go on a help sheet?
Yes.
Yes. Can the homework sections, the Mr. Heavy Pencils, can they go on a help sheet?
Yes.
No, they cannot. Right? Any examples must be left off of help sheets. Okay? Only definitions, key points. Occasionally, an example will be under a key point section, in which case then you could put that on a help sheet, but generally they are not. And one pager today. Gotta love that. All right. Well, here we go. That's all we can talk about. Rational and irrational. Think back to last year. What do you remember? What constitutes a rational number? What makes a number rational?
Doesn't rational it can't end.
Okay, so a rational number. I think you're actually more defining what an irrational number is. A rational number is a positive or negative value actually a positive or negative fraction of that, or decimal, and this is kind of what Nolan was referring to here. When you have a decimal, there are basically three types. Decimals can either end, they cannot end, or they can repeat. Okay? And so for it to be rational, it would be a decimal that ends or repeats. Okay? A decimal that ends or repeats is a rational number, as is any fraction, positive, negative, etc. How do you know if a decimal repeats? Do you remember that from last year? There's a little, yeah.
There's a line over the number.
Yeah, very good. Okay, so for example, the fraction 1/3, which if you've ever taken 1/3 in your calculator, is 0.3 repeating. You can write that as just 0.3, and then that little horizontal bar over the 3. That means that the 3 repeats, right? 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, forever. So technically, this decimal doesn't end, but because it has that repetition, it's still considered rational. Okay? Whereas an irrational number is a decimal that does not end and does not repeat. Okay? A decimal that does not end and does not repeat. For example, can anybody think of any irrational numbers off the top of their head? There's a really famous one that we always use with circles that is highlighted on a poster on my wall. Dominic. Pi, exactly. Okay, pi is probably the most famous irrational number. It doesn't end, it doesn't repeat. It gets its own little symbol here, right? The first 100 digits or so of pi are here, but they've had computers calculate it out to 2 billion plus places, and there's no sign of it ending and no repetition. Okay. But if it's not a number like pi, okay, to where you calculate something in your calculator, or you see it on a page and it's like 12.618292054236, right? No repetition going on. How do we show mathematically What symbol do we use, or how do we show that this decimal goes on forever? Nolan.
Like the IR.
That would be how you would say it's irrational. You would define it as that, but 3 dots, exactly, yeah, right? It kind of continues on. Okay, there's more to the story there, right? But we just don't have enough space. Okay. This kind of rings a bell a little bit. Rationals, irrationals, right? So. Also, the key point here, it says the square root of any non-perfect square. We're going to dive into perfect squares and non-perfect squares in CO2, but we're going to introduce it here. If you've got your calculator with you, can you take that out, please? Take out your calculator. And the calculator that I'm going to be using to kind of describe what we're doing here is one that was on the supply list. This one here. If you've got a different one, it'll obviously still do the same function, but the buttons might be in a different place, might push in a different order, something like that. Okay, with this calculator here. So, who can remind me, or who can tell me what is a perfect square? Sometimes it's easier to define a non-perfect square if you know what a perfect square is first. Either give an example or define it. What is a perfect square? Nolan.
A square.
Yes. And what do we know about squares? We can actually start there, right?
They have 4 sides.
They have 4 sides. Good. What else do we know about squares?
They have 4 angles.
They have 4 angles. What else do we know about squares?
The square sides are the same.
All right, all sides are the same. Okay? And that's where the term perfect square comes from. Because if we've got a square, say that's 3 by 3, and it's 3 all the way around, what is the area of that square?
9.
9. Right? The area equals 9. If we were to divide this into, 9 cubes or 9 sections, it would make a square. Okay? 9 is a perfect square because you can make a square with an area of 9 having sides 3 and 3. Can you make a square that has an area of 8? Can you make a square with 8 of those sections? What would the side lengths of a square have to be for an area of 8?
2 and 4.
Well, that's not a square, though, is it?
No.
But you're absolutely right, though, right? You can make a rectangle that is 4 by 2 because 4 times 2 is 8, but it's not a square. And in fact, you can't make a square that has an area of 8 using whole numbers, right? Nothing times itself equals 8. And so that's where perfect squares and non-perfect squares come from. If you can make a square with an area of a given number, it's a perfect square. If you can't, it's a non-perfect square. Okay? So how about 36? Is 36 a perfect square?
Yes.
Yes. What would the side lengths be of that square?
6.
6, right? Because 6 times 6 equals 36. So the symbol that you use, you've seen it before, the square root symbol. That's where this comes from here. Okay, the square root of 9 equals 3 because 3 times 3 equals 9. The square root of 36 equals 6 because 6 times 6 is 36. But here's what we're going to use the calculator for. We want to calculate the square root of 8. Okay, so to do this, first you want to look for your 7 key, your 7 button, the number 7, and immediately to the left of that is the x squared key, right? Which is actually the opposite of the operation we want. Remember, in PERBJAWS, exponents and radicals are opposite. But right above the x squared key is the square root symbol, okay? But it's on the calculator itself. It's not an actual button. So to access that, we have to kind of do what we do in a computer when you want like the dollar sign. You have to hit shift and then the number 4, and you get the dollar sign, right? You've done this?
Yeah.
Okay, right. And so your shift key is way up the top left corner. It's your second function button. Way top left corner. It says second on it. You have to press that first, then press the x squared key because you press this first. Instead of x squared, you're going to get the root symbol. And so in your calculator, the display should read this. A root symbol with a parenthesis. Okay? If you have got a calculator, make sure you can do this and raise your hand if you need some help. So second function button first, then the x squared key because it gives you the root symbol. Are we good? You got it? You got it? Girls? Down over there. Okay. You already calculated. Okay. Questions here. Good. Right. Good. Okay. And then take the root of 8 and close your parentheses. And because I saw Penelope, I think you had it up. Can you read what the decimal is?
2.828427125.
Okay. Which means that in order to get something times itself to equal 8, it's 2.828427125. Does that decimal end?
No.
No. It appears to, because that's all you see in your calculator, but your calculator ran out of spaces. Okay? Calculator is a great tool, but you have to understand its limits. It can't show you the exact value because this decimal does not end. And that brings me back to my original point, which I started about 10 minutes ago, I think. But the root of any non-perfect square will always be an irrational number. Okay? In your calculator, it's going to look like a nasty decimal. And I want you to understand, I want you to know this decimal does not end. It continues up. Right?
Yeah.
Woo! So there you go. Questions so far? Okay. So for your homework, and we'll do a couple examples here. Remember, I don't grade homework on accuracy. It's graded on completion. Okay? When you tell me that negative 19.7 is rational, I don't want you just to put an R. And then go on to root 36 and put R. And then go on to 16 32nds and put R. And then go on to pi and put I. Right? Why is negative 19.7 rational? The directions do say to explain.
It's like drag.
No. This isn't an iPad. You can't click and drag on your sheet. Okay, we're going to write it out. Why is negative 90.7 rational? What part of the rational definition does it fit?
The negative. No, wait. It doesn't end or repeat. Wait. It does end.
Yes.
And it repeats.
And all you have to do is write ends. That's it. That's all I want. I just want something that tells me why you put rational, because it ends. Okay? Why is the root of 36 rational?
It's the same thing. Wait.
As what?
Ends. It ends.
What do you mean it ends?
Isn't it the same answer for the first one? Wait. Oh.
Robbie?
It's a whole number, like the
What does it equal?
6.
6, right? Root 36 equals 6. That's all I need. It's a perfect square. Right? What times itself is 36? 6 times 6 equals 36, making that a perfect square, meaning it's rational. Now, if you put equals 6, and then you want to write that it ends, sure. Right? Because the decimal does end. But just root 36 by itself, we also have a root 12 over here, which is not rational, right? And just saying it doesn't end, well, how do you know it doesn't end? What does that mean? Okay. Why is 16 32nds rational?
Oh, I know this one.
Dominic?
It's a fraction.
It's a fraction. Okay? Sure. That's all you need. If you want to say that 16 32nds is equal to 1/2 or equal to 0.5 and it ends, that works too. Just give me something. If all I see is a letter written down, then I'm not going to give you credit for it. Okay? Tell me why you put that. And then why is pi irrational? We already talked, yeah?
Because it goes on forever.
Right. Does not end, does not repeat. Doesn't end or repeat. Goes on forever. Okay? Questions on that first part? Okay. Second part. Answer each question. Write the value of 9 3 ways. as a negative integer, as a fraction not in simplest form, using an exponent, and using a square root. Well, we're going to do this one together. So you've got the other three. But how would you write the value of 9 as a negative integer? And let's go back to last year. What's an integer? Let's start there. Anthony.
Yeah, whole number.
Well, whole numbers are integers, but that's not, like when you say whole number, what do you mean?
Like without decimal.
Okay, so integers are not decimals, they're not fractions. There's one other little piece to them. They can be positive or negative. So examples of integers would be like 6, or -6, or -10, or 15. Okay, any positive or negative integer, or any positive or negative number that's not a decimal. So the challenge is, how can we write a value of 9 using a negative number? Because we can't just put -9, because -9 is a different value than positive 9. But yeah.
Would you like put the thing around it? Yeah.
What's that called?
Parentheses.
Not parentheses. There is something we can put around the number though that's going to make it positive.
Yeah.
Give it a positive value. What are those things called? We learned about it last year, CO3. They look like this. What are those things called?
Lines.
They are lines.
Absolute value.
Absolute value bars, right? And absolute value, its definition is the distance from 0. So what this is saying here, even though we're using a negative value, we're saying how far away is this from 0? And how far away is -9 from 0? A distance of 9, right? Distance can't be negative. There's no negative side to a ruler. You can't measure the side of a square and have it be negative, okay? So how we can write a value of 9 using a negative integer is by using absolute value bars, right? Someone in the previous class said, well, could you do like -3 times -3? Sure, that would work, right? That's a value of 9, and you're using negative integers. I like it. Think outside the box there, okay? But your job now is to write a fraction not in simplest form that has a value of 9, so it's going to be an improper fraction, okay? Using exponents to give us a value of 9, and then using a root to give us a value of 9. But this is an example how we can use these mathematical operations and symbols to kind of manipulate things to get what we want. Okay, next one. In our number system, are there more rational numbers or more irrational numbers? And explain. So don't just tell me rational and then leave it like that. You got to explain why. Don't just tell me irrational and then leave it. You have to explain why. Defend your answer here. Okay. So essentially, if you were to take all the rational numbers in existence and put them into a bucket, and then take all the irrational numbers in existence and put them into a bucket, which bucket would have more? That's kind of what this is asking. Okay? But make sure you explain. And then lastly, for review, this goes back to last year as well, CO1, describe whole numbers and integers. Okay? For this one, if you don't know, it's okay to Google it. It's okay to ask your friends Alexa or Siri to help you. It's okay to do a YouTube search for pre-algebra CO1 on my YouTube channel, and then like and subscribe. That's okay too. Okay? If there's information you don't know, there's nothing wrong with looking it up, as long as you understand the information that's being given to you. Don't just regurgitate it, right? Actually understand it. Okay. I think this is a nice objective to ease back into things, a nice objective, especially with 15 minutes now to work on your homework, so we can all finish our homework and get the number game tomorrow. I'm not saying if we don't get the number game, it'll be the biggest failure in human history, but it'll be close for how much time you have to work on it now.
I was just paying attention.
Before we do the outro, any questions, comments, concerns, complaints, comments, congratulations, or criticisms? Thank you for that. Remember, thank you. You had your hand up, Penelope? Go ahead. Do you have a question? You forgot? Okay. Oh, you finished. Oh, good. Oh, did you explain everything? Where it says to explain?
I think so.
Just make sure you do. Okay. Anthony. Thank you. It's new, actually. I just bought it on Tuesday. Wait, today's Tuesday. Last Thursday. Yeah. Okay. What? Thank you. I'm wearing a new one tomorrow too. So it's the same pattern, only turquoise rather than red. Anthony. Thank you. Do you want me to say I like your face? Because I do. Yeah. All right, the outro. I say that's how you math. You say
Don't forget to like and subscribe.
with gusto. So let's do a practice run first. Ready? That's how you math.
Don't forget to like and subscribe.
We're in mid-season form here. Okay, here we go. For realsies. And that's how you